All right, this problem's crazy. So we have a system of equations, four unknowns, all x1, x2, x3, x4. But this one's a little trippy because it has a's and b's in some of the coefficients, where a's and b's are real numbers. Okay, so it could be anything. So it could be 2, 4, 6. What we're looking for, we want to find values of a and b where there's going to be no solution. So one, there's going to be no solution. Second, we want to figure out if there's going to be what a's and b's are going to work to make it only one solution. And then we also want to find out what values of a and b can make it so there's an infinite amount of solutions. Okay. So what I did, I put it in an augmented matrix. So all the coefficients on the left side. And then I put a bar to represent all the equal signs. And then to the right of the equal signs, I put it right there. Okay. So one way we could figure this out is by row reducing. And I've already done the dirty work. Just kidding, Mathematica did. So Mathematica did the dirty work for this, and it row reduced to this. No, that's crazy, huh? Well, let's see. Let's see if we can figure out first the no solutions. Well, what happens if we put a 1 into A? Looks like, well, on the bottom, it'll be a -1 plus 1. That's a 0. So the whole denominator is going to go to 0. Last time I checked, it's kind of a sin to divide by 0. It's one of the sins of mathematics. So no solution, we can tell that's going to happen when A is going to equal 1. Huge problem. Okay, same right here. What if A equals B? Replace A for B. We got B minus B. It's going to be a 0. Another problem. Looks like here again. Oh, A is going to be 1. Again here, A is going to be equal to B. Ooh, but now B equals 0. That would also be a problem. Okay. And again here, when A equals B. -B plus B, that's also 0. So it looks like for these three conditions, that would make it a huge problem of dividing, but yeah, we don't want to divide by 0 at all. Okay, so but notice everything else should work. Okay, so no solution for that, for those three cases. Let's see, and we could actually check that out. Yeah, I'm gonna share my screen, go to Mathematica. I call it Mathmagica. So the nice thing about this is we can say what happens if A equals, let's do one of the sins, 1. Okay, let's see what happens. And then I'll say B equals now 3. We'll see how. Okay. Ooh, notice right here, we have 0, 0, 0. And remember, there's supposed to be a bar here. So 0 equals 1. Oof. Also, last time I checked, 0 does not equal 1. Okay. All right, so let's move on to figure out the ones that are the solutions. So we can figure out where there's going to be one solution. Notice that there's no free variables. Notice that there's a pivot in every single column, every single of the variable columns. So it looks like there's probably not going to be an infinite amount of solutions because there's no free variables, at least if we have values of A and B. So it looks like if we have A not equaling 0, not equaling 1, A not equaling B, and then B not equaling 0. If all those three are satisfied, dude, it should work. Should we try it? Let's try. Let's see what Mathematica says. Okay, so let's see what happens when a equals 2 and b equals 4. Okay, let's see. Yep, it looks like it comes up with a solution. x1 is -2, x2 is 1, x3 is -1/4, x4 is 1. Yep, so that's one solution. Okay. So as long as those three are all satisfied at the same time. Okay. And yeah, an infinite amount of solutions. It says determine the values of a and b such that the system has infinitely many solutions with one parameter in the general solution. Write down the general solution with one parameter. Yeah, with that, I am not sure. They're not clear on what it means by a parameter. So I'm not sure. Yeah, because it looks like there can't be infinite amount of solutions given that there's a pivot in every single column. So I'd say none. D, is it possible for the system to have infinitely many solutions with two parameters in the general solution? Yep, for this again, I'd say that it's impossible. Impossible. Okay. An idea, I'm kind of guessing what they're saying for part C, says, what if we actually give one value? So, like, say we choose A equals something. Okay. And then we don't say anything for B. B could just be still anything. Whereas infinite many solutions in the general solution. Write down the general solution. Okay. So, okay, that's what I'm guessing. So let me share my screen, see if you can figure that out. Okay. So let's say that A does equal 1. Okay, let's see what happens. A equals 1. All right, it still thinks B is something. Okay, so I'm going to clear B. Whoa, look at all those. All right, so clear B. So this makes sure, because you notice how B is black, so it thinks that it's still in the system, that B is an actual number. So yeah, notice this light blue. That will make sure that it's not a real number anymore. Okay. So that's whack. Because notice that B doesn't show up. Okay. I'm just going to do that. I'm going to call, okay. I'm going to do this equals 1. And now I'm going to call this, B. Big B. Okay, let's see what happens when we row reduce B. And we want to make it look pretty, so put matrix form. Interesting, yeah. Looks like the B's go away. Oh, but notice that's still a problem. Yeah, it's still going to equal 0 equals 1. That's a problem. So, yeah, I guess if they were more clear on that, that would be nice to know what parameters they're talking about. Like, are they talking about A's and B's, talking about something else? So, but it looks, from my understanding, looks like it's impossible. So, okay. And that's it.